This is video 2 of your Unit 3 Pre-Cal review covering the test review for solving triangles. We're picking up with question 8 here. Video 1 had questions 1 through 7. So picking up with question 8 here. A pilot is flying at 183 miles per hour. The direction in which the plane is headed makes an angle of 38 degrees with the direction of the wind, which is blowing at 46 miles per hour. Use the parallelogram method to determine the ground speed of the plane. How far off course is the plane from the direction in which it tries to head? Alright, so it doesn't really matter how we sketch this as long as far as where we start from. So a pilot is flying at 183 miles per hour. The direction in which the plane is headed makes an angle of 38 degrees with the direction of the wind. So I am going to choose to make the wind blow back this way like this, or as far as the direction of the plane, and then make the wind blow straight like this, and that way this angle is the 38 degrees, and we're flying at 183 miles per hour, and we'll make the wind blowing this way at 46 miles per hour. So now we have the wind. I'm going to put a W here for this one, wind, and then I'm going to label this one plane so we know what we're talking about here. So 46 miles per hour for the wind, 183 miles per hour for the plane, so those are the magnitudes of the vectors, and those are separated by 38 degrees. So I have my two vectors. Now I make the parallelogram. So I should have moved this down a little bit. I'm going to end up drawing into my text here. That's okay. So it's not the best parallelogram, but that's okay. The resultant would be like this. So we're finding this value right here. So we can choose either half of the parallelogram, either section I should say. I'm going to choose to take this section right here. Doesn't matter. I could have taken this one up here, but I'm taking that lower section there, the way I've drawn it. So take that triangle out. We have, this would be our 183 side. This would be the 46 side over here. And this is our resultant value here. We know within our parallelogram, if this angle is 38, this angle right here is 180 minus that. So 180 minus 38 gives us 142. So this angle in the lower right hand corner of our triangle would be 142 degrees. So if you look at the setup, we have two sides and their included angles. So we need to be using law of cosines for that. So in this case, that's going to make R, the resultant, equal to the square root of each of the two sides squared and summed together. We're just filling in the cosine law here. Minus 2 times each side again, 183. I need more room here. 183 times 46 times sine of the angle, cosine of the angle between them. So that would be 142 degrees. So we'll need the calculator here. I'm going to pan over and we'll type that in. So we get square root of 183 squared plus 46 squared minus 2 times 183 times 46 times cosine of 142 degrees. Make sure we're in degree mode. And we get 221.1 miles per hour. So 221.1 miles per hour. That's part of the answer. And that tells us use the parallelogram method to determine the ground speed. So that would be 221.1 miles per hour. That answers the first question. How far off course is the plane from the direction in which it's trying to head? So that means we need to find this angle right here inside our triangle. So we'll use this angle right here. And realize it's trying to head, based on our picture, it's trying to head this way. It's this vector right here. And it's actually heading this way. So if we find this angle theta right here will answer that part. So we're going to need to use law of sines for that. So we know that r is 221.1, so we have a sine pair. We have this angle and the side that goes with it. So let's set up our ratio. Sine of 142 over 221.1, and that is going to be equal to sine of angle theta all over 46. And if you notice, I'm finding the angle for the shortest side, so I don't have to worry about an ambiguous case here, because I don't have to worry about solving a second triangle, I should say, because we're using the shortest side. So I know that whatever acute angle this gives me, that's going to be the right one. It's not going to be 180 minus that. All right, so let's cross multiply and divide here, and we get 221.1 sine theta. Actually, just cross multiply to start. 46 sine 142, and then divide it by 221.1, and we get, coming up here in green, sine theta is equal to 46 times sine of 142 all over 221.1. So theta equals the inverse sine of all of that. It's 46 sine 142 all over 221.1. And let's put that in our calculator. Sine inverse, so second sine, alpha y equals enter for a fraction. 46 sine 142 all over 221.1. And the angle is 7.4 degrees. So it's 7.4 degrees off course, off the course that it is trying to, spell that right would help, off the course that it is trying to head. All right, so that answers our two questions. 7.4 degrees off course, and it's heading at a ground speed of 221.1 miles per hour. So this and this answers our question. Now for question 9, what information about a triangle constitutes the ambiguous case of the sine law? So that would be two sides, when you're given two sides, and a non-included angle. That's the setup for the ambiguous case. So for example, if we have this triangle right here, if I was given this side A and this side B and angle C right here, if I was given that information, so two sides and an angle that's not between them, the included angle for A and B is right there, this angle. So this would constitute the ambiguous case. More specifically, when you're finding the angle, the angle is unknown and you're using law of sines, you have to be aware that it could be an ambiguous case. Well, technically, it is an ambiguous case, and you had one of three possibilities. Either it would make a right triangle, so you would have a 90-degree angle, and if so, you just solve the triangle from there. If you could also get an error through the process, meaning that the angle, the side length that you were finding, you had a side in the triangle that would not work. The given information made it impossible. And the third possibility, the third case, was you had to solve two triangles. So shortcut is, when you're finding the angle measure with law of sines, you have to be careful of those three possibilities. And it depends on what information you get as to which case you have. Now for problem 10, vector A consists of two components. They give us the horizontal and vertical component. Vector B has magnitude 8 and has a direction described by an angle of 120 degrees in standard position. Find the magnitude of the sum of vectors A and B using the component method. Alright, so we know that A sub x is 5. We know that A sub y is negative 11. So now we just need to find the horizontal and vertical component of vector B. So we'll make a triangle out of that. We have standard position 120 degrees. Standard position starts here on the positive x-axis and goes counterclockwise for positive. So there's 90. So 120 would be about right here. So that angle is 120. So that means this angle inside my triangle is 60 degrees. 180 minus 120. So this would be my b sub y, which will be positive, and my b sub x, which will be negative. So they tell me that the magnitude of vector b is 8, so the hypotenuse is 8. So to find the b sub x there, we'll use cosine. So if we set it up, cosine of 60 degrees is equal to the b sub x side over the hypotenuse. So b sub x is equal to 8 times cosine of 60 degrees, and we'll need to make sure and make that negative after we find the answer here. So 4. So we'll write that in the y column, in the x column. So b sub x is negative 4. Now we'll use a similar pattern here to find b sub y. We just replace cosine with sine because it's the y value is the opposite from this angle. So we get b sub y will be positive 8 sine of 60. 8 times sine of 60 degrees gives us 6.93. So b sub y is positive 6.93. And now we combine the two. So for a sub x and b sub x would give us our resultant x. So 5 plus negative 4 gives us 1. Our r sub y is going to be negative 11 plus 6.93, and we get negative 4.07. So we make a resultant triangle out of that. So we'd be going negative in the y direction, positive in the x direction. Let's do it this way. So that this side would be 1, and negative in the y direction. So we'll go down like this, and that's negative 4.07. This side is 1. So our resultant vector is headed down like this, and we'll find that by doing the Pythagorean theorem. So the square root of 1 squared plus negative 4.07 squared, that gives us, it doesn't matter if I make that negative, I'm just going to keep it positive to make it faster. That gives us 4.19 for the resultant magnitude, and that's actually all that they ask for. They don't ask for an angle there, so we're going to stop right there. 4.19 is the answer. We found the magnitude of that resultant vector using the component method. We'll stop video 2 right here with question 10. We'll pick up with question 11 in video 3.